Okay, what did you think of that? I presume there's going to be quite a lot of questions. I had about 1 per 5 seconds of the video, I think. I'll try and remember one or two of them. There's just too many, actually. Yeah, fortunately, it's a sort of a nuclear physics topic, this. And fortunately, we have Hermanus's best nuclear physicist in our midst, being Pierre. So we will probably direct your questions at him if they're too difficult for us. Okay, he's going to fire away. Peter, I presume you wrote down a whole lot of questions?
No, I stay out of this as usual. I'll let the people who know something ask questions.
Okay, by the way, I have done, with the amazing help of ChatGTP, I did a transcript. I changed, I thought I'd try a different method from my usual method of just copying the sort of totally unpunctuated text from the transcript of the automatic YouTube transcript, and then try and find out where to put in the full stops and capital letters and try and correct the spelling of the scientists and the various science projects and whatever. I thought I'll just stick it into ChatGPT, ask ChatGPT, please punctuate this. And it went and punctuated it. I couldn't find any mistakes. It corrected all the spellings of the various science projects and people and scientists. I couldn't find any mistakes. It was absolutely amazing. And it did it within about 2 minutes, where it would have taken me about 8 hours. So fantastic.
Very.
All right. Jenny, have you got a question?
I do, Derek, but it's nothing to do with the thing. I want to know where the photograph is that's behind you. Where was it taken?
This I took with my drone at Agulhas Park. It's
oh, right. I'm fascinated by the little bay.
Yeah, it's almost like a little volcanic crater or something. Yeah. Meteorite crater.
You. Sorry.
It is actually, it would actually be interesting to find out what the geology of that is.
Yeah, it's unusually round.
It is very circular. So I wonder if it is in fact a meteorite impact.
Thank you.
Okay, right. Let's go back to the beginning of. Okay, so I do have, if anybody wants to refer to it, I do have. I can pull up the full transcript. Anybody got questions on why they said the sun was green and they didn't really explain it? Or does everybody understand that the sun is green? Nobody questions it. Yeah.
It also depends on. It seems to depend on what observes it, whether it's the human eye or some fancy piece of equipment.
Yeah, the explanation they gave was a bit different to the one I heard a while ago. What I heard was that the green is the dominant frequency, which has got the, I don't know, sort of highest amplitude, or most photons coming out in that frequency. And then on either side of it equally, blue and green frequencies have the same energy as each other. And they sort of hang on equidistant on either side of the green, and those three, when you mix them together, almost like on a oil paints on a palette. If you took a bit of blue, bit of green, bit of blue, bit of red, and a fair bit of green, mix them together, you'd come up with yellow, the color of the sun. So that was it, and that's possibly the case with most of the, well, all the yellow-looking suns in the sky. Yeah. So, Pierre, any comment on that?
I actually I agree with you there, Derek, because that's how I thought, I've learned at school, is that the majority of the rods and cones in your eyes favour green, and there's a larger proportion, and that means that the green light apparently will be how we would describe white. When we see white light, because everything is, all of the frequencies are melded together. But if you've got a larger reception area in your eyes one particular colour, and that will be the dominant one you see.
Well, of course, it's a neat explanation for why plants evolved to have green chlorophyll, obviously to absorb the most energetic photon that the sun pushes out.
Yeah.
Just one comment about this. You might remember when we did the solar system model,
Yeah,
we consciously decided that we'll bow to sun's superior knowledge to determine the color of the sun.
yeah,
Two comments. I think if we observe the sun from outside the Earth's atmosphere, I think we would even see it as white.
okay,
It's a yellow star or a G5, I think, something like that. But they decided on the red color because that's how we observe it on Earth, and that's because of the atmosphere refracting away most of the blue and green light. But our eye's sensitivity is the highest, or response is the highest to green. And that's probably because we evolved over all these billions of years in the light of the sun.
yeah, makes sense. Absolutely.
Yeah.
Okay, while you're on the line, Pierre, the thing that tritium detectors that they wanted to build, they talk about like micrograms of it. Is it very difficult to make? Is it very expensive? Why do they only make such a little of it?
It is very unstable. So it is very, very difficult, first of all, to make it and then to retain it. Because there are so many neutrinos that can induce the reaction. I'm surprised that they were quoting detections of 10 events per year. That's quite a lot. So that means that the tritium must exist for that period, which I found surprising. But inherently, it's very unstable.
Again, well, can we ask you another question, Pierre, while you're on the air? There's a lot of things which I suppose he just didn't have time in this video to address it, but he did mention dark matter and neutrinos. Neutrinos could form a part of dark matter. I remember us doing a dark matter thing, and they explained why they decided that dark matter can't be neutrinos. Can you maybe just elaborate on? I mean, you've got all this stuff flying around, just going through everything, filling. You know, what did he say? How many passing through our bodies per second, and so on? What is? Can you remember the link to it not being dark matter, or only partially a partial component of dark matter?
A personal interpretation. First of all, I found it interesting that he said the total mass of all three flavors of neutrinos in the universe probably equals the total mass of all the stars that we see. In other words, all the baryonic matter, which is a huge number. Secondly, they are, let's call it, uniformly dispersed throughout the universe and throughout time. Whereas dark matter is definitely concentrated. That is
okay. So that was the primary reason why they thought it can't.
They can't be neutrinos. Dark matter can't be neutrinos.
All right. It might be time to revisit at some stage in a cosmology session the latest views on dark matter and even the quantization of gravity, whether it's really necessary and all this sort of thing. I've seen a few headlines of a few videos by some of our usual suspects that we used to watch, but I haven't had time to look at them, so it might be interesting.
Now, there's a lot of work being done on dark matter, so it might be useful to get an update.
Yeah. I mean, this video I think is based on the latest information, but it's like probably, you know, at least a year and a bit old. Which the right things are developing now that could be quite outdated already. Okay, David and Elaine have a hand up. The teacher wants to ask a question. David and or Elaine.
Okay. David, I was just wondering, you know, when they refer to the quarks, then they all have different colors. And I understand because there's a difference in charge, etc. But now he referred to different flavors of neutrinos. And I'm not sure what the essential difference is. I mean, if they're different flavors, what is the difference between the different flavors? I always thought they were different in mass, but apparently that's not so.
Okay, so yeah, again, we'll have to direct that to Pierre, but I suspect, look, what the sort of characteristics that atomic particles have are mass, charge, and spin. I don't know what else they have, but color and flavors. I mean, that's just a word to describe describe a difference to something. It's not actually a real color. Just a word to describe that is a property that thing has, which is different. So, Pierre, can you comment on that again?
Yes, I think the use of the term fiber was unfortunate. It's misleading. It's not just different colors or different flavors. They are different particles with different masses and formed in different processes. In exactly the same way that the quarks are actually different with different masses and different spins. So they are actually different particles formed through different processes, different nuclear reactions, all triggered by the weak nuclear force.
And what they call as well the mu neutrino and those things. I mean, there is an actual mu, what's it called, muon particle, which is different to the muon neutrino. Is that right, Pierre? That's
correct. If you have an electron involved in the decay of proton or neutron or any nuclear reaction, it will always be accompanied by the emission of an electron neutrino. In the same way, if you've got a tau neutrino involved, you'll get a tau neutrino being emitted to conserve energy. So the same applies to all three different types. Okay. Same principle of energy conservation.
Piers, so are they all the same mass, or is there? I know they're not supposed to have mass, but if they do interact with the Higgs field, do they then have different masses?
Now, he did show the masses at some stage when he was showing the standard model of particle physics, and they've got different masses. The electron neutrino is the lightest, then the muon, and then the tau is the heaviest of the three. But there are distinctly different masses.
Okay, thanks, Pierre.
On a South African note, I'd just like to mention, I just thought of it. A few weeks ago, Rob Adams sent me a WhatsApp message that he was involved with a group of South Africans who were sort of mooting to put a neutrino observatory in the spare tunnel, in the Tuiskloof tunnel. Apparently this has been planned for a few years already, and they're sort of getting towards getting permission and getting funds and getting things together to actually do it. So he might have actually also been a good guest to have at this meeting, but he's not normally available. I'll try and find that story and get some more information on it, because that's obviously a South African thing. All right, we have our own. Maybe we'll detect a. I didn't know there was such a thing as a neutrino what is it called? Cosmic new background.
The CNB.
Yeah, the Greek letter N, which is called NU. Yeah.
I didn't know that, but he made it sound logical.
Yeah.
Yeah, at the moment it's pure theory, because we can't get we can't get earlier than the CMB at the moment.
Well, that's why they're trying to detect it with this tritium and stuff.
Yeah.
The relic neutrinos, is that what it is? I think.
Yeah. Derek, I'm just going back to your thing about Rob Adam. I'd be interested to find out or hear more about this potential, because the other neutrino detectors are far away from everything. And the spare tunnel in the Tuiskloof tunnel is not, is only a few meters away from the actual one that's working. So I'm interested that there's a perception, or you know, that they can think about putting something there that's so close to other sources of energy. I thought things had to be really sort of far away, like the one at Ice Cube, which is down in the South Pole, and other things are way down mines.
Yeah, I'm just looking through Rob Adams' thing on,
Yeah,
and it's not in his messages direct to me, so it must have been
yeah, but it's
been sent to my old schoolboys group, which is part of,
yeah.
and then it's in amongst thousands of other rugby stuff and all kinds of things. It'll take me a while to find it.
No,
Actually, I
just
think you can
interested.
search. You can search. Maybe I must search for neutrino in the thing. I might find it.
Yeah, I just feel it just sort of to me raises a question about why all these other ones are so deliberately distant from everything else.
Yeah.
And this one is sort of effectively on the surface. And
I remember one.
Yeah.
We had a talk by one of what is our German friend's name again? He invited this guy, and he was working on the neutrino detection. And there was a guy from Stellenbosch as well that once addressed the club that was measuring neutrinos from from Coburg, and they had something also nearby. But I think maybe
that's interesting.
Let me just see if I put in search.
Yeah.
Neutrino search. Oh, how's that?
How's that?
Pole Africa Underground Laboratory. It's called PAUL.
Oh.
And there's a whole list. Download PDF. I'll download this and send it.
Oh, that would be great. Thank you.
Establishing a deep underground physics laboratory to study, amongst others, double beta decay, geoneutrinos, reactor neutrinos, and dark matter has been discussed for more than a decade within the Austral-African physicist community. The Pole Africa Underground Laboratory is an initiative for seeing an open international laboratory developed. It has the advantage that the location, the Huguenot Tunnel, exists already, and the geology and environment of the site is appropriate for an experimental facility. So I suppose they've got enough rock over them or something to
I'm not just interested
eliminate the other cosmic rays and particles which might disturb your detector.
Yeah, that'd be interesting because, as I said, it's much closer to this. It's much less distant than a lot of these other places are that they've set up these detectors.
Yeah, well, when the guy was dramatically talking about a 45,000 ton of water detector, I thought, wait a minute, a ton of water is a cubic meter. That's 45,000 cubic meters. What's the cube root of 4,500? It is actually 16.5. So if you have 16.5 meters by 16.5 meters by 16.5 meters, you've got 4,500 tons of water. So it's not that big, as he dramatically announced.
Interesting to find out more about Paul.
Yeah, I'll download the PDF and have a quick look at it, and if anybody's interested, and I presume we could just send the transcript of this video also to everybody.
That would be great. Thank you. To both.
All right.
Is this the end of the series now, Derek?
Sorry?
Is this the end of this series?
This is number 14, and I think we have 17, so it's getting there almost.
Oh, there are some more. Right.
Yeah, I've got 3 to go.
Oh, okay. Sorry, I wasn't sure. I just didn't know how long they were.
Sounds like you're getting tired of them, Jenny.
No, I'm not. It's been absolutely fascinating, and I just thought, is there still more there is to talk about?
I mean, there's so much talk about it. It's amazing they can fit it in 17. It's called the history of the universe.
Yeah.
And we're covering it in about a year.
That's why I wasn't sure. That's why I asked if there's, if there are any more. But I like the way that they look at it. They sort of link history. They bring individuals.
I really like that the history, the people who covered things and how it happened, and those little anecdotes make it very interesting.
Okay.
Peter Harvey's got his hand up. Peter, have you got a question?
Yeah, I actually do. Right at the beginning, he says the sun is green and your brain is lying to you. I'm not quite sure I understand what he's getting at there. I didn't sort of follow his argument. Can you explain that?
Well, I don't know.
Can I answer it? Try and answer it.
You answer that. You had the answer just now, I think, when we just talked about it briefly.
Yeah.
Go ahead, Jenny.
The thing to bear in mind is that what we see in terms of what we see is not actually what the eye sees. For instance, the eye sees everything upside down because of the way optics and lenses work. So what we see is processed information. For example, when you blink, you don't see, and this is a conscious thing, but when you blink, you don't see black gaps every time you blink. Because obviously when you're blinking, light isn't penetrating the eye, isn't going into the brain. So the brain manipulates and manages the information to produce what we see. So in effect, we're not seeing what we see is not actually what we see, if that makes sense. And if you want to call it a lie, then that's fine. But what we see is the result of what the brain has processed in relation to information. So it turns it upside down, it cuts out very short blinking time. So yeah, there are delays.
Yeah, and did you catch
okay,
our initial discussion, Peter, that we had about the way the colors mix? And although green is dominant as a frequency emitted by the sun, it doesn't look green because of the other colors mixing in with it. And also because down on Earth, because as Pierre pointed out, because of absorption by the atmosphere of certain frequencies, and the sun would actually look less yellow and more white if you're outside the atmosphere. Is that right? Yeah, if I got it wrong.
I've heard that explanation before, and yeah, I understand where the explanation is coming from, but I just feel that it's sort of a non-consequential observation because evolution has developed our senses via the brain to suit the circumstances, but this is the way of evolution right through.
Yeah.
And so I don't know, I can't understand the significance of the comment. But okay, I know. Thank you, Jenny. I appreciate your answer there.
I think he likes to throw in dramatic comments to keep the audience interested every now and then. And then he probably had all intentions of explaining some things at a certain point, but had to edit a lot of stuff out to get the length correct.
Yeah.
There's just too much. I think that's why I had, a lot of questions, things which people like Pierre might automatically know the answers to. But I'm going to go through the transcript again, and if I can think of interesting questions to ask her, and I'll research the answers, and I don't know, maybe see if we can send them on.
Did you say that you'd like me to send the transcript through to everybody?
Yeah, I think why not just send it to all the attendees?
Yeah, that's fine.
Oh, yes, I agree.
Yeah, I really
and we'll just send maybe a link to the recording of this discussion afterwards as well. Okay, how are we doing for questions now? A lot of people haven't asked questions. Peter, are you still with us? Peter's another.
I am, yes, thank you. I'm just listening.
Is this Peter Strauss? Okay.
Yes, thank you.
All right, sorry, I thought it was Peter. Oh, Peter. All right.
No.
Sorry, wrong Peter. Okay. Right, also we've got a lot of attendees today. Terry from another part of the country. Up from another part of the country. How's it? Was that okay for you? Did you learn something, or have you got something to teach us about it?
It was very, very interesting, but in this company, I'm hardly going to venture an opinion, but I really found it absolutely fascinating and illuminating.
Okay. All right. Okay, good. All right, I'm sure everybody's eager to go off to supper or a cup of tea or a beer or something, being almost Wednesday.
Eric, thank you. That was interesting. Very interesting armchair video clip to enjoy. Thanks.
Yeah.
Goodbye, everyone.
All right.
Oh.
Glad you enjoyed it. See you next time.
Yeah, bye.
Thanks, everyone, and thanks
everybody.
very much for joining us.
Thanks, Derek and everyone. Good night.
Good.
Thank you.